Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Industry 4.0 and Beyond in Advanced Manufacturing. My name is Amanda and I will be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures, and to elders past, present, and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's partner, Queensland University of Technology, QUT. QUT is an ambitious institution with a growing research output focused on technology and innovation. QUT ranks in the world's top 200 universities, and their strategic plan enables QUT as the university for the real world and charts its provision of transformative education and research that is relevant to our communities. With more than 50,000 students across 2 inner-city campuses in Brisbane, QUT offers academic programs in fields spanning business, creative industries, education, engineering, health, law, science, and social justice across 5 faculties. Today, you will hear from 2 speakers, followed by our live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Volker Richter. Volker is a passionate and visionary business leader with more than 50 years of automotive experience, specialising in product development, production and quality management. Volker possesses in-depth experience regarding reorganising, streamlining and strengthening various business units, as well as an extensive knowledge in product development, with a focus on lead time reduction, developing and implementing product development processes for new vehicle platforms, and establishing efficient dynamic strategy for total vehicle development. Please welcome Volker Richter.
The BMW i Factory. It's a master plan for the automotive production of tomorrow. The BMW i Factory production strategy defines the future orientation of plants and production technology at the BMW Group. It meets the challenges of the transformation to e-mobility. Automotive manufacturing of the future requires a new holistic way of thinking. With our factory, we are leading the way and setting new standards in flexibility, efficiency, sustainability, and digitalization. Over the last few decades, the BMW Group has considered itself the benchmark for innovative, flexible, and efficient production technologies in vehicle manufacturing. And it is from this level that the company is now redefining operational excellence. The strategic vision of the global production network is the BMW i Factory: lean, green, digital. It's an integrative global approach. The BMW i Factory is not a one-off showpiece, but an approach we will implement at all our plants in the future, from our 100-year-old home plant in Munich to our forthcoming plant in Debrecen, Hungary. The BMW i Factory focuses the BMW Group's production expertise on 3 key topic areas: lean, which stands for efficiency, precision, and extreme flexibility; green, for sustainability, resource efficiency, and circularity; and digital, for the active use of digitalization in data science, artificial intelligence, and virtualization. As always, at the BMW Group, the holistic approach of the BMW i Factory is underpinned by the consistently high standard of flexibility, launch, expertise, and integration capability in the company's production system. So let's start to dive a little bit deeper into these 3 elements: lean, green, digital. Lean. The BMW Group's production network is on the cusp of a fundamental transformation. The Neue Klasse, due for production launch in 2025, is based on a completely new vehicle architecture. With its clear focus On the all-electric drive, it sets the conditions for future vehicle generations to be manufactured efficiently and in line with the company's profitability and quality goals. The BMW iFactory is now set to strengthen the proven success of the global production network. Our production network has three key strengths: maximum flexibility, excellent processes, and outstanding integration capabilities. We are the absolute benchmark in all three, and they are the focal points of our BMW iFactory. The key topic of lean is about high flexible, efficient production through streamlined processes, competitive structures. Flexibility remains a key competitive advantage of BMW Group production now and in the future. And in several aspects, the company's production structures are so flexible that a single production line can produce different drivetrains and vehicle models. It also sets a standard in terms of rapid responsiveness and adaptability, absorbing supply bottlenecks and shortages, comparatively spontaneously, and reacting quickly to fluctuations in demand. And for customers, this flexibility means they can change certain elements of their vehicle configuration up to 6 days before the production date. The aim of the BMW iFactory is to use even more meaningful real-time data from throughout the production process to control global manufacturing more closely and transparently, achieve the fastest possible response time. This will enhance not only volume and market planning, but also supply chain and inventory management, and support targeted work on quality as well. So let's talk about the second pillar, green. Sustainability along the entire value chain. Avoiding consumption, saving resources, and using state-of-the-art technologies. With the BMW iFactory, the focus on sustainable production is stronger than ever, reaffirming the BMW Group's position as the most sustainable manufacturing of premium automobiles. Environmental, economic, and social responsibility are inseparable, and we strive to achieve all three not only in the product itself, but along the entire value chain. By 2030, we aim to reduce CO2 emissions from production by 80% compared to 2019. With its new plant in Debrecen, Hungary, where the production of all the electric Neue Klasse will launch in 2025, the BMW Group is entering a new era in sustainable automotive production. Our plans are for Plant Debrecen to be the first automotive plant in the world to dispense completely with fossil energy sources in its production processes. Debrecen will be our first CO2-free vehicle plant and puts us clearly at the vanguard of developments in this regard. A significant share of the plant's electricity will be generated directly on site. The remainder will be covered by 100% renewables, the vast majority of which will come from regional sources. Our contribution to the energy transition makes not only environmentally, but also business sense, because our approach ensures stable prices and secure supplies. Another element of sustainable production is consistent circularity. Wherever possible, production materials and resources will be reused. Metal offcuts, fillings from milling, for example, will be recycled and reused, while waste heat from cooling will be fed into a circuit to heat indoor spaces and water. Saving resources significantly benefits a company economically, but smart, effective solutions also make production at the BMW Group unique in terms of environmental credentials. Examples of the technologies realizing our commitment include the resource-saving wet-in-wet painting process, IPP, and the use of direct current in-car body constructions for the very first time. The energy that powers the BMW Group's plant around the world is sourced purely from renewables. As Plant Leipzig develops into a center of excellence for hydrogen, the company's facilities worldwide are becoming increasingly independent of third-party energy suppliers or other external influences. This is enabled by a combination of self-generated and stored energy with flexible load profiles throughout production. Here, the latest digital methods and comprehensive systems ensure maximum transparency and support the consistent reduction of energy consumption, as well as the needs-based use of renewables on the basis of accurate forecast. A further key issue in the field of climate protection is biodiversity. The variety of flora and fauna at BMW Group sites worldwide is being promoted through targeted region-specific measures from beehives and falcons to meadow orchards. Meanwhile, to support green logistics, both within and outside the plants, the BMW iFactory adopts an open-minded approach to technologies, focusing on environmentally sustainable concepts. Within the next few years, for example, increased use of rail transport and electric trucks will mean zero local emissions from transport logistics at Plant Munich. And now we're coming to the third pillar, digital. From innovations to effective use cases. Customized premium vehicles, delighted customers, excellent quality, and on-time delivery have always been the goal of digitalization at the BMW Group. The BMW iFactory is advancing digitalization by taking data consistency to a completely new level along the entire value chain and across every one of our process chains. We use digital innovations to create effective use cases in production because of us, innovation and efficiency go hand in hand. Production at the BMW Group uses the latest technologies to link all the relevant product, process, quality, and cost data between development, planning, and production processes. The main focus here is on applications from the field of virtualization, data science, and artificial intelligence. Virtualization plays an important role within the BMW iFactory strategy model. In a first step, every detail of all the BMW Group's production sites is being recorded in a 3D scan. In this way, planning work can be carried out virtually at any time and from anywhere. The next logical step, a virtual representation or digital twin, is created of each factory in its entirety. This can be used by planning specialists in real time, collaborations across different locations and time zones. This approach takes the planning of all structures, production plans, and even individual processes to a completely new level. It allows virtual products to be integrated in the factory early on. For example, significantly reduces planning work further down the line. It also allows investments to be optimized and enhances process efficiency and the stability of product launches. In partnership like the one with NVIDIA, the BMW Group combines its pioneering spirit and process expertise with cutting-edge technologies. Applications and augmented and virtual reality support employee training for future processes and technologies. And digital production system planning allows global partners to be integrated into the value chain early on. Meanwhile, data science provides the foundation for fact, figure, and real-time database decision-making. Consistent, transparent data allows the root cause to be identified quickly and proactively so that processes can be optimized. BMW Group Production is already an industry pioneer in the effective use of AI and currently uses more than 200 AI-based applications. The technology allows various logistics and production processes to be automated for better quality assurance. In addition, standardized platforms and self-services mean solutions can be scaled rapidly for application across all technologies and locations. Business is all about people, so the employees have a very important impact. Fit for the BMW iFactory, our fourth pillar. At the heart of the BMW iFactory are the people who create it. Future-focused and highly qualified, the BMW Group workforce is ensuring a competitive and successful transformation. The production division is investing heavily in with foresight in upskilling staff for quality, logistics, maintenance, E/E, e-mobility, and digital planning. Thanks to state-of-the-art instruction methods, employees benefit from electronic training programs that leave them free to train independently and on their own initiative. Extensive additional development options are also available to help them maintain and enhance their skills. More than 50,000 BMW Group employees have already undergone the training they need to work in electromobility. The key factors behind the transformation of BMW Group production are the developments in automotive market and specifications around climate change. The BMW Group is already doubling its production of electric vehicles in 2022, having delivered more than 35,000 fully electric cars to customers in the first quarter alone. At the same time, the latest technical innovations are supporting the company as it contributes significantly to climate protection and sustainability. The BMW iFactory delivers not only on the increasing customer demand for electric vehicles, but also on our desire as a member of society to support climate protection and sustainability. We are using digitalization to make this happen while remaining absolutely competitive. In order to understand these 4 pillars on the iFactory, I would like you to join a video which describes and showcase what we mean by iFactory.
The world needs change. Climate protection, emission-free mobility, and digitalization are demanding an enormous degree of flexibility from us.
That's why we want to change the world with our innovations.
Lean, green, digital. These are the pillars of the BMW iFactory.
Lean means efficient, precise, and flexible. Flexibility to manufacture different drivetrains and architectures on one production line is key to the transformation towards e-mobility. In this way, we are laying the foundation for the Neue Klasse. For green, we are relying on state-of-the-art technologies that are resource-optimized and circular. We are systematically using green energy at every location.
This will enable us to lower CO2 emissions per vehicle by 80% by 2030. We've been using 100% CO2-free electricity since 2020 and are tapping local potential with district heating and geothermal energy.
The BMW iFactory is digital. We are using data science and artificial intelligence to become even faster, even more accurate, and even more transparent.
Merging the real and virtual worlds opens up a whole new dimension. Employees around the globe can connect virtually to develop and plan in real time on a single platform. This is a real revolution. It's our answer to the metaverse.
We are making the transformation of our production successful. We all are designers of the BMW iFactory.
The DNA of the iFactory can be experienced at all our plants, not only at our future ones like Debrecen, but also at our 100-year-old main plant in Munich.
BMW iFactory, lean, green, digital. That's the future of our production.
Thank you, Volker, for a great presentation. I'd now like to welcome our second speaker, Associate Professor David Holmes. With almost 18 years of engineering research, teaching and design innovation, David has gained significant experience in engineering systems design. In recent years, David has led interdisciplinary teams to deliver electric vehicles and autonomous vehicle systems design and specialised in a range of mechanical design and manufacturing areas, including numerical simulation, mesh-free particle methods, smooth practice hydrodynamics, finite difference, discrete element method, finite element method, ANSYS, fluent enhanced oil recovery, and model-based systems engineering. Please welcome Associate Professor David Holmes.
Thanks for the introduction. As noted, I'm Dave Holmes. I'm an Associate Professor of Design and Manufacturing at QUT, and I'm really excited today to talk to you about Industry 4.0 and beyond, and some of these ideas in advanced manufacturing that are developing at the moment. Now, before we go any further, I'd just like to acknowledge the Turrbal and Yagara people as the First Nation owners of the lands that I'm coming to you today from. And QUT pay respect to their elders, laws, customs, and creation spirits. And we recognise that these lands have always been places of teaching, research, and learning, acknowledging the really important role Aboriginal and Torres Strait Islander people play within the QUT community and more generally. Okay, so advanced manufacturing. Volker's just given us a really great kind of idea of what BMW are looking at and what their priorities and really focus now and into the future is in terms of their manufacturing, their operations and vehicles. And so what my place in all of this is over a year ago, QUT decided to put together a new suite of master's programs and really acknowledging that advanced manufacturing is a critical kind of developing field and one that the industry needs a lot of more kind of talent and knowledge in. And so I've taken a lead role in developing this, and a key part of that is that we acknowledge that developing these courses has to start with industry. It has to start with best practice and move back into what curriculum and skills we can develop in these high-level students. And so a key part of that is earlier this year, I was able to spend 3 months embedded with BMW in Germany to really understand what a leading organisation like BMW is doing in the advanced manufacturing space. And I'll talk in a second about Industry 4.0, Industry 5.0, but really the German automakers are leading the innovation in the Industry 5.0 space. And so understanding what that actually is was really critical to what we as a university can produce in this kind of postgraduate space. Now, before I go any further, we're talking about Industry 4.0 and beyond, so it's really important to put a definition around that for this presentation. And so whilst these are by no means definitive definitions of what this kind of idea of industrial revolution and its evolution are, these are the ones that I'm working with today. And so, you know, these are fluid ideas, but this kind of gives us a bit of groundwork for the rest of the talk. And so when we talk about Industry 3.0, we're talking about sort of from the 1970s, the idea of automating manufacturing processes, introduction of robotics and these types of concepts. Up to today, and now we're looking at the Industry 4.0 space, and where Industry 3.0 was the automation of process, Industry 4.0 is the automation of the business side and management of manufacturing. And so we're talking about data analytics, artificial intelligence, cyber physical systems, and really this idea of digital transformation. And then now and into the future, there's emerging the idea of Industry 5.0. And where before you're applying automation and digitization, now we're kind of developing on that. But a really key focus is on humans and human-centered manufacturing with mass customization and personalization, introducing humans back into the manufacturing process where you can utilize the benefits of a human operator as well as, you know, cobots and machines to really realize the benefits of personalization. And probably the key aspect here is around sustainability, and not just sustainability as a key performance indicator of our manufacturing, but sustainability as a really core business imperative, a place to start from rather than just a feature of. And that's part of what we've just seen in Volker's presentation around and what BMW are looking at in the lean, green, digital. And it's critically important in all manufacturing moving forward that sustainability is a core value, because it's a core value of our customers. And we see that customers are making purchasing decisions based on the environmental impact and sustainability of a product. So it must be a starting point with manufacturing. And that's the key kind of conceptual change to Industry 5.0. And I guess the challenge is, how do you do that? How do you actually implement that kind of an idea? And so part of what I was doing in Germany and part of what I was trying to understand is how BMW approached this and how we might translate that to an Australian audience. Because obviously a massive organisation doing brilliant things, but how does that translate to a traditional manufacturer, a small to medium-sized enterprise, and what are the sorts of skills that someone would need to operate both at BMW's end of the spectrum and at a more traditional manufacturer. And really what became very obvious is what BMW is doing in terms of lean, green, digital, and in terms of their operations is more of a natural evolution of something much more traditional in manufacturing, and that's coming from lean. And so when we talk about lean manufacturing, we're talking about kind of well-known practice set of guiding principles to decrease waste and increase productivity and so forth. And Toyota innovated that in the mid-1900s. BMW's been operating on the value-added or value-based production system, which is their proprietary version of lean, and it's very customer-focused, value to the customer oriented. And so every single thing that is done in the organization, the value to the customer is at the fore. And so this is what's been operating at BMW for years and years. And into the modern approach to manufacturing, that's evolved into what Volker talked about, lean, green, digital, where green is just an evolution where environmental waste and energy waste and pollution and things are just another waste to be kind of rationalized within that kind of lean concept. Digitization is just a facilitator to achieve lean and green. And so it's built very naturally out of it. The other very interesting thing that I found there is it's implemented really in the first instance culturally in the organization. So led right from the very top. Every single level of the organization has a buy-in to this idea of starting with lean and moving towards environmentally friendly digitization for benefit. And they use a whole range of tools in a heterogeneous way, but everyone's moving towards a single outcome, which is value to the customer, value to the organization. And it's a really beautiful example of how this can all work together. Obviously, very complex organization with thousands of employees and many systems to achieve their different engineering and manufacturing processes and actually get to this goal. And so the next question that I had to answer is, how do I translate what best practice you see in an organization like that and moving towards and innovating in Industry 5.0? How do we translate that to a more general audience? And so that's kind of the framework that I'll talk about in the remainder of my part here. And so what became very apparent as I've been speaking about is it all started with lean, but then it's scaffolded on top of that in a really, really value-based way. And so if you are going to take lean and develop, and then one of the best tools that you have as a starting point, or at least a very valuable lean tool, is this idea of value stream mapping. Now, this is a very, very simple value stream map that's good for a PowerPoint slide, but not much else. But it's just to illustrate the idea that this is where you can start. BMW apply this at a very high level. Many organizations who have gone on a lean journey will have value stream mapping analyzed for their particular processes, right? And so this is a great starting point because it starts to give a bit of visibility to a process. It starts to give a bit of visibility to things and ideas like value-added time, non-value-added time, and how each of the processes is instigated and relates to each other, and parts move through the organization and so forth. So this is a very good starting point. Very simple, very traditional, used in many places within manufacturing. Now, adding to this, what we might do is introduce this idea of hierarchical value stream mapping. And now this, again, isn't new. And many organizations, in fact, most manufacturing organizations have really clear idea of what their process elements are as well, and how that process is carried out in terms of steps and in terms of the time taken and the operator engagements with tooling and all of that kind of stuff, right? And so, again, a traditional idea, but using it as a single framework and tool and bringing them together starts to be very powerful. And so if you're looking at each of those manufacturing elements and analyzing the specifics of it, then we might start calling this hierarchical value stream in that context. Now, This book, Lean Robotics, which is produced by the Robotic Company, is actually has a really nice framework for developing both manual kind of manufacturing cell details and also robotic cells and things like that. So that's where a little bit of these ideas has come from. I just wanted to reference that. Now, if we're talking about hierarchical and we start talking about really complex organizations, then you're not going to be able to capture all of the different details and link up that process level with the kind of factory or overarching value stream level. And so this is a point where you might actually start introducing some of these kind of additional layers in the hierarchy. And this isn't typically done a lot, although different models and tools are used at these different types of levels in many higher up organizations. What I'm using in this context is sort of bringing them together in the one framework, because we're going to build on this and scaffold a lot of these other ideas into this space. And it's important to have the full kind of range of information. So when I talk about hierarchy, really, I just mean that capturing the process level and working out how that engages with the full value stream, because it's each one of these elements that we're going to start doing a bit of analysis on. And so this is the idea of hierarchical value stream. Now, moving on from that, what we want to do is really kind of build on that and get as high a resolution as we can, so high resolution value stream. And so this is just a different example that you might look at. And in this example, I think it's the example of manufacturing a radiator, right? And again, it's just a example, a tool. But if we start building ideas of parts in warehouses moving to line side storage and material incoming, what are the particular communication strategies? And this is a very simple pull kind of indication between each of the things and some of the production kind of connection. But at this point, you can actually capture what's going on, how each of the manufacturing processes is started, how they get their instructions. You got either Kanban and supermarket stores and production control messaging and all of these kind of ideas that you can actually capture in this higher kind of resolution version of value stream mapping. Again, absolutely, traditional lean approaches just at that high level starts being very, very valuable. And if you maintain that high level, either at the different kind of hierarchies and certainly down to the process level as well, and maintain some process map and how that relates to the whole value stream, now you have a really valuable tool that you can build some of these ideas on. All right. And so this is the starting point. It's not revolutionary. It's just a way of having a singular framework that does what a complex organization like BMW does across many different tools. But it's very difficult to package many different tools into the context of a simpler organization or a master's course like what we're looking at. So this is kind of an example starting point. Okay. And so if we're starting with lean, we might as well start with the types of lean analysis that you can do. So analysis based on lean principles, and that's, like I was saying, total time, value-added time, transportation, inventory and inventory value. And you're looking at doing these at each of these process kind of elements or cells, so in an agent-based way. And particularly the transitions between cells and things as well are really important to start accounting for these things. Your production coordination and triggers, people movement, equipment movement, wait times, and all of these kind of traditional ideas around lean. Human task complexity is a good one, because if it's a very simple human task, then that's an idea that maybe automation is going to have some benefits and things, right? And so you've got these lean analysis principles, you're increasing your visibility on a process, and now you can actually use some lean tools to then impart improvements in a very, in what happens with a lot of these types of things in industry. Right, this probably isn't news to anyone, but where things start adding kind of value is when we start thinking about, righto, so where does some of these more sophisticated industry 3.0, 4.0, 5.0 ideas sit? And kind of taking the lead from the way that BMW approached things and a few other organizations, what we can start with is industry 5.0 and work back. And we're starting with 5.0, particularly because one of the most closely related to lean principles, as I've said, is sustainability, right? And so if we now take the tool that we just developed in terms of that kind of value stream mapping and start looking at it from the lens of sustainability, we start to get something you might call a holistic value stream map. And as an example, if we have all of our kind of elements and we treat it in that agent-based way, and we look at each of those processes in terms of inputs and outputs, then we are doing what might be a typical kind of sustainability analysis of our manufacturing workflow, but we're doing it in the context of lean, and we're doing it to increase visibility on the entire process. And so when I talk about inputs, it might be, at each of these process levels and anywhere in between that might be relevant. What are the raw materials? What are the parts coming from a third party? Is there packaging? Is there input? Energy, water and chemicals, fuel? Are there dyes and tools that get changed regularly? Are there process consumables and maintenance consumables and so forth, right? So what are the inputs in all of those? And all of those inputs will have their own life cycle kind of analysis that we can carry out. And what is the progress and where have these things come from? Where have they traveled from? What energy was used by the suppliers to produce them? And so it starts increasing the ability to have resolution on that. Organizations like from the auto industry, all of their suppliers, they have required that they get the information, all of the sustainable aspects of what the incoming supply chain parts are, so that they can have full visibility on what energy and consumption and CO2 and all of those things are. So that's really important. And in terms of outputs, we're also, all of those things then also have potential for waste. And so if we're analysing that at the process level, what is the raw material waste and parts waste, packaging, what lost energy and water and chemicals and so forth are coming out, how frequently are the a chemical kind of wash being changed out, where does that go, what is our process around managing those wastes? And it's a typical sustainable kind of life cycle analysis, but if you do it in this value stream mapping process as the fundamental framework, then you start to really build resolution and value to the design process in manufacturing or the audit process. Right, and I suppose you can look at it in terms of, if I go back one, if you look at it similarly in terms of resilience of your supply chain. So a good example in the auto industry is the chip shortage that we suffered through COVID. And so can your manufacturing be resilient to multiple different suppliers of the same thing or different options of materials and parts and things like that? You can look at that at this level very easily once you identify where all of those kind of inputs are coming from. And in terms of human-centered kind of manufacturing, that I guess goes previously to the lean aspect. Where is it that we might be able to integrate humans and robots in this line to improve either our sustainable or our kind of lean principled approaches to things? And after you do that, that's when we can move back to some of these Industry 4.0 ideas. And when we move back here, the reason that I'm suggesting that we do this after the Industry 5.0 ideas is because when we're talking about digitization, it has to be for a reason, right? If you're going to actually start collecting data and start doing these things, it has to be to achieve a goal. And oftentimes that goal is to improve lean, to improve your sustainability. These are the sorts of things that highlight problems, and then collecting data on the things that you don't know will then allow you to get a better understanding of what's going on. And some examples here in terms of information opportunity that you might be able to turn into data with some sensors and things is things like energy, force, sound, timing of things, quality control, usage of chemicals, waters, coolants, and so forth. And these are the sorts of things that you can take data on. But if there's a really a thing you don't understand in terms of lean or the sustainability, that's starting to suggest you should take data on it. Quality is another good example where you can really use data analytics and machine learning and things to actually analyze the quality as something's moving along the line, rather than when it gets back to QA checks at the end, because that will then allow you to kind of catch it much earlier and save time, money, effort, waste, all of those kind of things. And so when we're talking about data, in the very simple sense, is just visibility, understanding what's going on, similar to this value stream mapping idea. You can impart simple and kind of increasingly complex analysis on that, either to better run your process or increase your understanding of things. Maintenance and quality are really good areas, and so doing things like predictive maintenance rather than reactive maintenance, you can do with some of these ideas. And then production control, and Industry 4.0 has been adopted by industry fairly widely at the higher level, but perhaps less certainly in the Australian context in a lot of places at the process level. So doing this allows you to kind of look over the entire process, identify the information opportunity at each of one of these processes, how that relates back to Industry 5.0 ideas and lean ideas, and then really execute on a cost benefit kind of basis. And then I suppose the last step, which kind of seems counterintuitive, but moving on to automation, is now that if we understand from a lean standpoint, we understand from a sustainable standpoint, we have used information to really evaluate what's going on in those. Now we can choose very wisely where to perhaps improve our processes with some automation, with robotics, with cobotics, and that kind of thing. And again, I refer to this lean robotics. It's a good, simple example, but there's lots of companies out there that consult on this basis and do really great work in this space. But the idea would be develop both, if it's a manual process, develop a manual task map and a robotic task map, compare the two, really understand what that benefits of a robotic or automation would be in that space. Evaluate the cost benefit and return on investment, and then actually drive that implementation. But the reason to introduce automation or robotics isn't necessarily because that's where the industry is going. It's to solve a problem. It's to identify a problem and fix it with that automation. And so by building from lean back to this, that's how you can have a really, really effective kind of cost benefit to implementing what is a very costly operation in any manufacturing organization. And so what I guess I'm proposing here or suggesting is that Industry 5.0 is really kind of the evolution of these ideas, and that if we want to implement them in a way that kind of mirrors what the organizations like BMW are doing in the Industry 5.0 space, then we still need to start with the traditional kind of lean and move through 5.0, 4.0 to 3.0. And that then gives us a really effective way of kind of getting the best value of the investment that is involved in these things. And so while the framework that I'm proposing here or kind of developed based on my time at BMW is not revolutionary, and it's using really kind of existing approaches to things, bringing it together is of value. But I guess the biggest value of what I'm suggesting is that priority setting, the priority setting of starting with lean and moving back through this kind of sequencing. Then it allows you to be kind of developing sustainable practices, using digitization in a really effective way, and using robotics and automation really where you need it first, low-hanging fruit, and really getting the best benefit. And if you look at this in terms of what BMW have been kind of doing, lean, green, digital, and automation. But they've been doing automation forever, so that's kind of less of the now in terms of that. And so The resulting framework I'm suggesting, we might give it kind of a snappy acronym: hierarchical, high resolution, holistic value stream mapping, 3HVSM. And as I say, lean, green, digital, and robotics is kind of this idea. And really, that's the take-home message that I got from BMW, that kind of culturally driven approach to starting with lean and everything being for a reason, everything coming from value to the customer, and using the really modern tools that we have at our disposal now, but only for the absolute core reason of making things better for the customer, making things more cost effective for the organization, which in the end brings value to the customer because you're making your products cheaper. That cultural reference is what BMW work towards, and it's a huge value. And so, like I say, whilst this framework may not be anything particularly revolutionary, the idea of starting there and moving back is potentially of value to some. And really, that's the basis for where QUT's new Master of Advanced Manufacturing sits. And so the course, as we're developing it, really starts from that and then builds some of these tools around it. And so I'm just kind of finishing my talk with a bit of a plug for our course, if anyone's interested in that. And as a bit of an example, here are some of the units that we've built around this. And the idea is that framework is the starting point. And then a couple of units around that. Leadership in digital manufacturing is really how do you implement those ideas of lean and sustainability, Industry 5.0, in terms of managing the process. A capstone unit, Industry 5.0, in terms of really resilient, human-centered and sustainable design in manufacturing. Industry 4.0 in engineering practice around the digitization and robotic manufacturing. And the idea is that the framework that I've talked about is kind of the starting point. It's the thread that brings them all together. But each of these units really dig into the tools and AI and machine learning, analytics, and all of those kind of things that you can actually solve problems in manufacturing and really innovate in this space. And so the framework I've presented here is really about visibility, opportunity, and priority setting. And then the course that we're talking about is about the tools to solve those problems. All right, so that's my talk. There's a couple of links and opportunities there if anyone's interested in those master's courses. But otherwise, thank you very much for your time. It's been my pleasure to present some of these ideas.
Thank you. Thank you for those great presentations. As always, it's now your turn to get involved. Please ask our speakers questions via the chat box, and if you could put down who your question is directed to, and also maybe your first name and where you're watching from. Thank you also to people who submitted questions whilst registering. And we might start with David, and good afternoon to Howard, and Howard is watching in WA. And David, Howard is asking you the question, why are many industries proving to be slow in adopting Industry 4.0 practices? What do you think is holding them back? David?
Yeah, absolutely. So I guess some of these ideas in Industry 4.0 around collecting data and then doing analytics with that data, it requires, I suppose, a fairly high-level kind of connectivity between traditional systems and modern systems. And we have a lot of legacy equipment in manufacturing. So if you talk about a manufacturer that has potentially a lot of automation already, some of those tools and PLCs and other things are coming from multiple different vendors, and then the ability to link them together requires kind of centralized servers and different drivers to plug in, and then the ability to send that somewhere and be able to engage with cloud tools and analytics at that space. So from a technical standpoint, there's a barrier to entry in just being able to work out what architecture is going to work for the organization and how all of those tools, some of them legacy, some of them more modern, work together. And so it's challenging, and there's a lot of new expertise that an engineer working in that space needs to get. The other thing is the expense of all of these different tools, and then being able to really identify what it is that you want to achieve from that data is another kind of area. So it can be quite challenging and a significant barrier to get to that point. But as I said, I think it's perhaps not as it shouldn't be as difficult as some of that does suggest. And really identifying the types of data and the types of information that's really going to help with the process in the first instance, and kind of defining a bit of an architecture of how you're going to get that data can be of quite a lot of value. And so you can get some big gains very quickly with a little bit of good information in the right space. And so hopefully the sorts of things that we're talking about today and the idea of bringing a masters online and putting some additional expertise in the industry can help accelerate some of those aspects as well.
Thank you, David. And over to you, Volker. And I just wanted to shout out thank you for logging in at 5 a.m. Volker's in Germany, so a big thank you from all of us. We have a question, Volker, asking you, what are the opportunities for Industry 4.0 in batch manufacturing? Volker.
Yeah, thank you. I think there's a great opportunity. I mean, we showcased at BMW already how much impact we have in our production system by using all these AI technologies and other things. We have over 200 applications meanwhile, and it really pushed our data analysis and production system to a new level. I can only advise everyone being in this area really to acknowledge the power of data, the power of AI. We're just at the beginning of a complete new arena, and seeing all these major impacts shows me personally that there's even more to come. And Dave already made the statement, everything has to come top down. I completely agree. If you have a top down approach, and you probably could see it during my presentation, we are boosting our employees and associates with digital training. If we combine this together, there's really a lot you can do in the batch industry, and scale it up to let's say mass production. So I personally think very powerful, and without using AI, I don't see actually the usage of the existing data, and we really are at the beginning. We're not finished. We're at the beginning, and that's makes it even more interesting to enter this as soon as possible for everyone.
Thank you for that. And David, I just want to move on to you. We've had a question that's coming asking, has the change to digitalisation changed the type of workforce required, i.e. more data scientists, less automotive workers? And of course, Volker has just mentioned the digital training of the engineers. David.
Yeah, so I'd say there's potential for new skill sets. Absolutely. I think as Volker's just mentioned, that an organisation like BMW is recognising that the people that actually are working the lines with some good quality targeted training, then they become your best asset to a digital transition as well, because they're the ones that the people that might be implementing the machine learning, AI, data analytics consult with to understand the problems. And that's a really key kind of facet of this. The other thing that I kind of was very obvious talking to a lot of the really talented engineers at BMW is that it's not kind of a new talent that sits over here and then existing talent that sits over here. The engineers, a lot of times, particularly the engineering leaders, have to be the conduit. So they're the conduit between the people working on the line, and then potentially the data analysts and other things. So we have not just data scientists, but we have engineers that have to be able to speak both manufacturing and also data analytics, and be the conduit between the two, so that you can actually achieve the goals that you want. And so type of workforce changing, I think absolutely. I think done well, you can take your existing workforce on that journey, and managing stakeholder expectations, and actually, kind of taking the organisation on a journey, and as we've said, sort of led from the top and culturally is really the best way to do that. I think we can really do this, but certainly engineers that understand the tools and the processes and can actually engage between groups of people, that's as important a skill set as anything.
Thank you for that, Dave. Volker, do you want to comment on that as well?
Yeah, absolutely. Like Dave already mentioned, the digital boost we do to our engineers and to our entire company mainly is the bridging element of the different faculties. Means basically a typical mechanical, electrical, mechatronic engineer needs the digital boost in order to speak to all these data scientists. These languages in the past were completely different, and they were not even able to talk about what they actually did. And by using this digital boost, we have a common language around AI, around digitalization, around virtualization, and it makes things much faster. And people can talk and finally build joint teams together in order to go the next level. So it is extremely important to have a common base, and by boosting a company across all levels and functions, that definitely helps to transform a company into the next stage of digitalization. Absolutely.
Thank you. Thank you for that. And back to you, David. We've had a question that's come in from Ahmad, asking you, with the significant and swift AI, and Ahmad uses the word takeover, David, what are your views on the level of automation industry will reach? Will there be a point where human intervention will be nearly zero?
Yeah, so interestingly, the ideas around Industry 5.0 actually go a little bit the other way, and it's this idea that we, in certain circumstances, we've reached the level, certainly with robotics as it stands, where you actually are starting to bring people back into the manufacturing process to work with robots, and we've got cobots, co-robotics, that where those robots are actually safe to operate, not in a closed off caged environment, but alongside the human workers. And so with the real hunger for mass customization of things, from phones to cars to just about everything we could talk about, people wanting their specific version of it, then that can only be achieved by having humans do what humans do best, which is think about the complex problem, and then having robots and automation there to do the manual, repetitive, and heavy lifting, right? And so I think AI certainly will increase automation. I don't know that it'll remove human intervention entirely. I think that human intervention may end up being at a higher level and to the benefit of that customization. I think AI has got huge advantages from the understanding processes, improving efficiencies, and designing things better and in a way that is more environmentally friendly and more functional, and certainly using it as a design tool can accelerate advances really significantly. But yeah, I think at the moment that Industry 5.0 idea is actually bringing some of that human ingenuity back onto the manufacturing line, and I think there's a lot of benefit in that.
Thank you. Volker, do you want to comment on that? The need for...
Yeah. the amount of data we're talking about in production is massive. I mean, we're talking about terabytes of data, and a human being actually can't handle these amount of data by themselves. AI is a huge help, and like I said before, we're just at the beginning of a new era of AI technologies, and having AI technologies, AI apps installed will definitely make manufacturing more lean, more green, more digital. And the engineers on the line are no longer watching just the robots. We're talking about co-roboting. We're talking about the data scientists together with an engineer are using all these data already filtered, structured, managed through AI in a way that you can faster find root causes, faster implement quality approach into the line, faster implement planning of the entire factory, and so on. So AI is a perfect example how co-roboting might work in the future, in the near future, and how engineers will get a different type of work into the existing engineering work. So I deeply believe you can't ignore AI. You better jump into this topic and find your benefit in this, and there will be more to come. We're just seeing all the benefits, and there's more. So co-roboting, like Dave mentioned, new types of engineers in manufacturing. These things are already there, and we are further developing the big potential of AI.
Thank you for that. And Volker, just staying with you for now, we've had a great question that's come in from Adrienne. Good afternoon, Adrienne. Asking you, Volker, does BMW's zero emissions target also include emissions and pollution from the manufacture of the subcomponents like batteries, tires, metal, etc.? Volker?
Yes, it includes. The value chain is complete here. We are talking to our suppliers, sub-suppliers, third-tier suppliers. We give them targets, how to create an emission-free environment. In the battery technology, it's hard. It's tough. We're picking specific suppliers. We're actually awarding them. We are ignoring suppliers who are really not going this way. So by making make or buy decision, or a decision based on different suppliers, more transparent, we clearly tell everyone it's not only about the price, it's not only about the quality, it's also about how do you go the zero to emission way. When do you reach your CO2 neutral balance in your production chain, and so we are pushing this a lot. We are transforming with our approach, our supply chain too, and we are very often picking the ones who are doing the approach like we are doing in our production system in the same way. So I think it all comes how do you do this, and there are other examples, and I don't want to mention any company names where it's only about the price tag, it's only about the price for the components. No, we do this really holistically. It's also about CO2 and how is these specific components produced, engineered, also logistic wise. And what is a plan this supplier can show us for the next 5, 10, 15 years. So we're considering this through the entire value chain.
Thank you, Volker. Dave, you mentioned a couple of minutes ago manufacturing. We've had a question, and it's a pretty broad question, Can you comment on specific ways to improve sustainability within manufacturing? Thanks, Dave.
Yeah, I think Volker's given some really good examples so far, and it can really come in multiple different layers. So in the first instance, you're talking input energy, input water, and emissions, and so understanding what those are and rationalising those. Certainly, energy, we have options around renewables and things. Water and really understanding the circularity of water in our operations is really important. And then emissions and how you actually manage that, capture that, or eliminate that based on whatever processes are, and choosing processes wisely. So that's kind of the baseline. But then you're talking about where the materials that you're using are coming from and percentages of recyclable. Another thing that BMW does brilliantly well is the idea of not just circularity in the input materials, but understanding the recyclability of their product. And so if you're designing and manufacturing a product to be 100% recyclable, then whilst right now it might not be circular, the idea is that in the full life cycle, then you can close that loop, and now you have full circularity in a really effective way. So there's a lot of really practical ways to achieve those things, but starting with visibility and understanding what you're doing currently, and then putting targets around, like BMW and all of the other automakers and governments and so forth have targets around, the emissions targets around energy consumption and sources and things like that. That's a really good starting point for that.
Thank you for that, David. And just staying with you for now, we had a question that's come in from Anthony, who's watching from New South Wales. Good afternoon to you. Asking, can Industry 4.0 be extended to the construction industry? And maybe you could put that in the context of structural health monitoring. Thank you, David.
Yeah, so construction industry, I'm a mechanical engineer, so I sort of will speak carefully about any applications in the construction industry, but certainly structural health monitoring in structural engineering and larger infrastructure projects is a huge buzz topic at the moment, and so there's big projects all around Queensland of including whole arrays of sensors on civil infrastructure, and then using that data in the cloud and digital twins to actually understand the current health of the infrastructure, and then the remnant life and things like that. So that's all Industry 4.0 concepts straight away: sensors to the cloud, analytics, and big data analytics. So in a construction context, that's the one I know about, and I'm sure that there's other really strong examples in that space as well. As a mechanical engineer, I've got less exposure to some of those others, but I'm sure absolutely that these tools are really valuable in many different circles.
Thank you, David. And we've got a few questions coming in, which is fantastic, about the actual master's course. So what I recommend you do is just sort of put down in the chat box your details, how we can contact you, or just your full name, so we can see who you are on the registration, and then QUT will come back to you. We haven't got too long left, but I did want to ask a question on behalf of Engineers Australia. We've talked a lot about the lean, green, digital, future skills, etc. Very rapidly changing, fast-paced sector. Starting with you, Volker, what advice would you give to our young engineers coming through?
Yeah, a perfect example is we have a very long history together with QUT. Meanwhile, we have over 100 interns brought to Europe to our facilities. And the takeaway for them is really being really open-minded, being wide oriented with the engineering knowledge. We are looking for system engineers. We're looking for mechatronic engineers. We're looking for people who are really into the digital world. Engineering is more fascinating than ever, and as wider as you can build your platform, your knowledge, and put the digital portion as part of your journey early on, as better you are established for the next big step into the real world. And I like actually the QUT saying like the university for the real, and I really can tell you what I could see over the last 10, 12 years coming out of QUT has a real world touch and has the ingredients we as a company operating in the real world need, and can also only acknowledge to continue this journey and to make sure that we get lots of these excellent young students from all the universities worldwide with the appetite for transforming, appetite for digital tools, appetite for making things leaner, greener, and really participating proactively on improvements and optimization. And I think with this full-rounded package, a young engineer is best optimized for the career start in major companies. So I can only advise be open-minded and use the digital tools as an accelerator of your career.
Thank you, Volker. Great advice. David, I'm sure from QUT, your thoughts. What's the advice for our young engineers coming through?
Yeah, so I guess, as Volker says, engaging with as much new technology as possible. So things are changing very rapidly. AI is changing very rapidly. I think we already seen in the software kind of space that if you're not using AI as a co-pilot in software development, then you're being left behind very rapidly. So there's these development tools that are of huge value to engage with and try and stay current with. But in the same time, kind of everyone I talk to that is working in that space emphasizes before the tools and before the skills in software or digitization or engineering in general. For the most part, it's the criticality of talking to people, the ability to actually talk to people in different departments and synthesize on the basis of the information that you get from them. So that engagement and the ability to bring people together to listen to the problems and propose solutions on the basis of the actual problem. And so it might not be that you're being told what the actual problem is. So getting to the bottom of what the actual problem is, understanding the system, and then engaging with the stakeholders. I think that quality in an engineer far surpasses some of the technical capability that someone might develop. Now, both are important, but that teamwork and that engagement is a really critical thing to work on. So listen to people, talk to people, try and understand problems, and talk to as many kind of interdisciplinary teams as possible, and you start to get the right language down. I think that's a very valuable part for young engineers, aside from the things that Volker's just spoken about.
Thank you for that, David. This afternoon, we've talked about Industry 4.0 and beyond in advanced manufacturing, and we've covered a lot of stuff. And starting with you, Volker, can you just summarize the 5 key things you want to leave our audience with, the 5 key messages from today's presentation?
Yeah, thanks, Amanda. Like I said before, advanced manufacturing has a beautiful future. It is not only about lean anymore. It is about a holistic view, holistic perspective. We as a company decided to create an iFactoring with this lean, green, digital, and people pillars. Things like this might be appropriate for other companies too. I can only advise everyone to see AI as a big chance to improve your efficiency, your digitalization, your output in your company. Don't see it as a threat, see it as a big chance, and push your organization into this digitalization by boosting your company through all levels of employees. And for the young engineers, the time to get finished at the university can't be better. We are looking for you guys. The appetite in the industry for fresh, energized, digital mind open engineers is bigger than ever. So get connected as soon as possible with the real world. QUT is doing an outstanding job connecting with industry partners. Creating an advanced manufacturing program is an excellent step too. And I think with all that in the package, I think the AI, the advanced manufacturing has a big chance in Australia and can go from there. So big takeaway, basically, look for companies who are doing this for years and benchmark yourself with them. And for the engineers or the young engineers, young students, you are needed and get energized and ready for this big AI digital approach. You will be very happy and will enjoy this ride.
Thank you, Volker. David.
Yeah, so thanks. I suppose the first thing I'd say is there is opportunity for every sized organisation and every type of engineer working in this space to engage with Industry 5.0 principles and 4.0, right? So BMW do an amazing job. All organisations aren't BMW, but all organisations can use some of these ideas to get benefit. So that's the first thing I'd say. The second thing I'd say is that engineers have such a brilliant opportunity. We're on the cusp of real transition in productivity. And so the opportunities, as Volker said, that AI brings is not just computers doing our jobs for us, but AI and digital tools as a co-pilot to improve productivity and actually accelerate our ability to make change. And so a real need, I think there's a real need for engineers to engage with the tools right now. If it's as simple as opening a ChatGPT window and creating an account and just playing with it and asking it questions and seeing what it can do. And so that opportunity is there to engage and really accelerate where the industry is going in manufacturing and other places. And I think in manufacturing specifically, I think there's a real opportunity in Australia to advance our industry and really do some great things, because Australia is brilliantly good at kind of high quality, high value products. And I think there's kind of an emerging kind of explosion of that. And so people with skills in manufacturing and skills in digitization can only enhance that. And so that's not 5, that's 3, but that's kind of the three real key things that I think are really exciting at the moment in this space.
Thank you, David. And what a fantastic 2 presentations we've had this afternoon. It is all we have time for today. So please join me once again in thanking Volker Richter and David Holmes for giving up their time and the fabulous content and insights they put forward. I'd also like to thank Engineers Australia's industry partner, Queensland University of Technology, for their contribution. A friendly reminder that Engineers Australia's flagship event, the Climate Smart Engineering Conference, is coming up this month on the 29th and 30th of November. It'll be held at the Melbourne Convention Centre. So please, we encourage you to visit our website and strongly consider attending, especially with the themes that we've had for today. As always, we're looking for your feedback. so that we can improve and plan. So if you could just take 2 minutes to complete a short feedback form, which is linked in the description box below. Thank you again for joining us, and I look forward to seeing you at our next Thought Leaders event. Thank you and good afternoon.